arrived to the last session of this meeting.
And I'm the chair in the good way.
I'm self-chaired. I'm not going to talk, so I'm kind of semi-chaired. What we will do is we'll go over the conclusions or summaries for those 4 workshops that we had on galaxies and cosmologies, and then on science, on stars and planets. And then we had L3 discussions, and then we had discussions of science programs that could be used to enhance or prepare for LSST science. So we have 4 sets of slides, and we'll start with galaxies L3 requirements. Who is doing presentation? I don't have name here. Richard, okay. And then when we are done with this session, then Darko will say a few farewell words, and Petty Lyson will formally close the meeting and announce the location and time for the next LSST in Europe meeting. Okay, Richard, please.
Okay, so this is Tuesday. Oh, right. You can one again. So I want to comment on the markets. The UK, 48% of the population would stay in Europe, and that will stabilize the whole thing. I'm part of it. I'm my family. People always, first time they ever voted, have to reassure them that you don't always get what you want.
No, turn it on the side.
Okay, so basically, we're really just thinking 2 main topics that came up in the galaxy section. One was a concern that basically the background estimator, assuming it's just one, would have an effect on, say, central regions of clusters where you basically you subtract light off say the dark galaxies. The issue you may also subtract off intercluster light. Also, you may filter out. So if you're trying to say filter out galactic cirrus in areas of the sky, you may remove large outer tails. And then the other passive object is large dwarf galaxies. Now, in some sense, all these categories of objects really affects maybe 5% of the sort of area of the survey. And so in terms of your metrics for a survey, you don't want to optimize for this set of objects. And so at this point in time, we're not too sure exactly what the plans are. And so here's just ideas. We don't know exactly what you guys are planning. I'm sure you guys don't know yourselves at this point in the project. I hope you know exactly what you're going to be delivering in 5 years' time.
It's all in LDM 151.
Yes, but hopefully there's something else. So you either save the sky as a product that people can add back in again, possibly. This is just a suggestion. Some of these will probably be old-fashioned ideas. I'll get told. Another possibility, maybe this actually comes up later, is for instance, if you have some sort of residual image, which you can actually construct, which is basically you take the catalog of parameters, you construct an image, and effectively subtract that from the science image, and then you can look at that. And actually, you can actually construct this yourselves, but it might be useful to have a tool that does it. It would not be efficient. I think it's very good to go off and write it. It's not a complicated thing to do. I've often thought of it. In fact, I'm thinking that I might write one of theirs. Hopefully, afterwards, I'm younger would write it. People get bored with these things. Okay, so the other issue was the ability to rerun source detection with possibly different parameters, different kernels, different deep learning parameters. So, whatever parameters, what I'm talking about here is The source detection software, I assume, has a range of parameters that can be tuned. So we're not talking about necessarily writing new algorithms here. I'm assuming that the group's going to be writing really fantastic source detection software, which has taken all everything in the last 50 years, and it's just a tuning. So what I hope is not going to have to write source detection. And so that's again, something's back to the same thing. I think it's also a useful thing for people to do, that you should just not take it from out of the pack. People are going to understand the LSST data. Some people, it would be useful for people to basically do these experiments. It would be useful for the project as well. Okay, right. I just want to just copy to you to repeat myself. Okay, so then, problem of course is what happens in the next 5 years. So I think in the galaxy population, it would be nice to have L2 products of what I would say LST-like L2 data, either simulated products, i.e. whatever they are, this is all the documents that I'm just going to write down. I would be expecting co-add images, all the auxiliary products attached, like PSFs, weight maps, and masks, and catalogs. That's nice. That's pretty boring working with simulated data. In my experience, it's not like real data. So I would actually not put necessarily too much. I wouldn't put my shoes on with this data. What I think would be exciting would be to have LST like real data. And I think Subaru data would be my first choice. And I think it would be good if in 2 years' time, that's my time scale, where in a position to have data like that. That's I put my highest priority for the project. If I was the highest priority, one of the 9 priorities. And I think it would help development of the next stage. That's not mine. I think I'm trying to summarize what we discussed at that session. They're all contributed together. Others of you, if I've misrepresented what we want, speak up now.
Thank you. That's excellent summary. Any comments or additions to these slides? Mike.
So we are really planning to do something like that for the next 2 years to have a precursor data set process for the LSST pipelines and be doing that going forward. Now, is there, if for whatever reason, HSC I think is very likely to happen, but if for whatever reason it doesn't, and instead we use that candidate as a very process DES as a large part of DECOs, would that be fine as well?
I mean, Subaru fields, for instance, probably would be a useful data set. But the image quality, I think, HSC is better. I think a lot of this really attractive. It's moved there as much. And also not to process I can make available to people, so I guess. It's a collaboration. Yeah, I mean, but I think HSC was really nice. So I can imagine that, the issues, the DECAM people will not we don't know the different communities. Like Michael would like doing both. That makes sense because the people who already got access to HSC data and doing their science, it'd be boring for them to do the LST
Well,
products.
there may be some advantage in processing DECAM as well because there's a completely different pipeline and different genealogy behind it, and so being able to compare
No, I think both. I would argue both. I'm not saying one or the other. I'm saying that's what I think.
I mean, the only issue with that is that typically the seam is above 1. I mean, by design, we do the supernova fields when the seam is bad, so you're going to end up with a very deep.
There is a distribution. I mean,
There is a distribution.
How big standard?
Yeah, but I mean, what's the HSC seam typically?
But it's worse than
I think you might get 1 or 2 BEMs with that.
my best is
Anyway, just bear that in mind.
Thank you so much. Okay. Anthony, you want to go next?
sky at a specific time, whether that was on an active pixel in order to, for example, de-bias surveys, etc. And there may be others depending on the L3 use case. The second point was that LSST, of course, is going to be a very interesting archive for retrieving the sky history of any point in the sky over the period that LSST is observing. So by sky history here, I mean really specifically the history as seen by the LSST. An example case is where you find an alert in another survey and you want to find out what was going on in the neighborhood of that alert. So you'd like to have an image, cut-up image from the LSST, but you would also like to have, for example, all the light curves of neighboring sources so you can try to identify the progenitor. And you may also want to calculate diagnostics from level 2 data, which can aid you in identifying that source. And that leads into this third point, which I presume is easy enough to implement and maybe already available, which is this basic manipulation of level 1, level 2 data products, calculating the quantities from the existing ones so that you can, for example, make these extra diagnostics for identifying alerts. And then another point that came up was that it would be very good to have, of course, interoperation with other catalogs or data archives, and it's of course already foreseen that you can actually bring other data into the LSST system as level 3 data products. And basically the requirement here would be to support the development of some kind of cross-managed facility, or maybe we just leave it to the data center in Strasbourg, I don't know. So some way to have basically a fairly seamless experience when you try to combine LSST data with other surveys to do an analysis of that. And here were just some background notes that I added for those not so familiar with LSST. So cutout server, so retrieving small images from the LSST archive is planned. So the most recent coads are basically available instantly. But if you want an older coad or older epoch image data, that might be of interest in some cases. It might take 10 to 20 minutes to retrieve it from tape. Because what Mario told us, and this is very impressive, I think, and probably more than good enough for all the applications. Crowded fields, this is one thing that came up as one of the possible L3 products, is that you do a better job on crowded field photometry. That's because LSST will only do a best effort on crowded fields, and of course they will run into some limitations. This includes reclosing of the raw data with specialized crowded field algorithms, maybe even including an optimized PSF estimation, processing of the various photometric bands together. My understanding is that these are being done separately, and of course this would require that if you want to do something like that, having PSF model or PSV model. What else was there? Yeah, there is no variable star classification done by the LSST teams. We only get basically the light curves, and the photometric time series are basically only treated by per band, so not with all bands together. And of course, this was mentioned already this morning. For example, could the Gaia pipeline be used in this respect? It's not entirely trivial to do so, but someone will have to take up this task of doing variable star classification if you really want to make good use of the light curves. And the understanding is also that with respect to solar system, that the LSST processing already does the right thing for fast moving or trill objects, so there are no extra requirements on that point. So that's it.
Yeah. Comments, questions?
There was a disagreement between Jaco and this Jaco thought We are not hearing you. It's a pull shout.
Yeah, I'm sorry. There's a disagreement. I disagree with that second from last bullet point. It's kind of important. So the question of how far we will go into crowded field photometry is, as Mario told you, best case. But we're not going to do something really stupid. And I believe that we are going to handle the bands together. So stay tuned, I guess, is the answer.
Okay. Well, I can, I'll remove that particular line.
Well, yeah.
We could provide our excellent documentation that describes all this.
But that may
That's our best piece of documentation.
Well,
Thank you.
food for thought anyway.
Thanks. Then we have two presentations on general science programs. Antonella is one, but I don't see Antonella.
She's here. She's here.
Oh, okay. And then you have.
Okay, so both Wes are already gone, so I agree that I would present the summary because I was at this workshop as well. So again, there's a few slides on with background that was intended for the workshop. Those were left in, so I will go through those. Okay, so we went through a couple of science. Well, there's one science case that additional science case that came out, suggested by Michael Brandvik, which was to way to obtain here simultaneous color information, which is particularly interesting for solar system objects, but I would gather that for example variable stars this will also be interesting. But this does require repeated exposures in different filters on the same field, which is not something that is naturally done with the LSST survey. So there, migrating over the idea that whenever a filter switch is made, that you basically go back to the last sort of 20 pointings and repeat those so that you have quasi-simultaneous time series for different colors. But this will require some simulations to see how well this will work and whether it will actually satisfy what's expected from the solar system side. Okay, there were two science verification proposals for the early part of the LSST survey. So Giuseppe suggested to do a survey of the inner bulge region, which can only be surveyed by LSST, and it has over such large areas and has the additional advantage, of course, that you have the Y and Z bands, you can go a little bit deeper through the dust. You could survey lots of our Lyra stars, which will be faint in that area behind the extinction, so it won't saturate the system. And you can also try to study Cepheid beyond the galactic center. But there are also many commissioning reasons why, or science verification reasons why you might want to do that. You can test their photometric quality in really crowded fields, of course. How well can you do the rendering determination? You can compare with other existing data. And of course, such a survey would have an immediate science value as well as part of the science verification. The second was a related topic, looking at globular clusters of halo field stars. So there's plenty of science, of course, that can be done. And Giuseppe pointed out a particular feature, the main sequence bending at 0.4 solar masses, which is introduced by opacity effects, and you can see it in G-nu color. And that, compared to the main sequence turn-off, is a nice age indicator. And this can also be applied to the field population. And again, if you observe globular clusters, of course, you can do a good test of your capabilities to do crowded field photometry and as well as astrometry. The one thing that does come out of this as a requirement is that you need sufficient observation of the U-band to really probe deeply into the halo. Okay, there are two short exposure science cases. One related to the solar system objects, which was again suggested by Mikael and Wes. And this would require about 2-second short exposures. So down to faint magnitudes would be, of course, very useful when we start doing science with the LSST. And of course, we will get very good constraints from Gaia on the galaxy model, but not out beyond magnitude 20, at least not directly observed constraints. And also further modeling on asteroid collisions will seem interesting in the context of LSST. We discussed a bit the auxiliary data, and basically there was no need really identified beyond what is already planned, and we're using, probably using white dwarfs for the flux calibration and tying the photometry to be very homogeneous, all sky photometry Gaia is going to provide. And then also follow-up was discussed, and basically the conclusion was that, of course, the follow-up of anything that LSST finds, as we know, is expected to be done by the community. The only thing that might lead to feedback to LSST is that based on the findings during follow-up campaigns, you might want to take into account that your cadence reviews, which at the moment are planned every year, whether there's something that can be done to optimize cadence for specific cases. Of course, if the interest is big enough there. I think that's it. Yeah.
Thank you, Anthony. Antonella? Comments, questions? Okay, let's then move on to the last set of slides.
Okay, so first of all, Bob and I would like to thank everyone who participated in this workshop. I think it was quite productive, it was lots of discussion. So what we've done is we've distilled what was discussed into three points. All right, so these 3 points are permanent redshifts, spectroscopy follow-up of transients, and low surface brightness imaging. All right, so since undoubtedly true that LSST will provide better photography, it says, but as Joko pointed out, the community will need to start building the photosynthesis pipelines that we need to exploit LSST data. Okay, so we need to start thinking about what kind of code we need to develop, if codes need to be developed, that can exploit the deeper data that we're going to get from LSST. So the key issue right now is to collect the calibration sample. Okay, so we don't have enough spectroscopic data. We felt to do good enough calibration to the kind of accuracy we need to get good photosynthesis from LSST data. So current data probably, current data is not adequate to go down to I of 25. It's probably only good enough to go maybe down to I of 23, perhaps. So there's a big challenge ahead to collect a good calibration sample that will allow us to produce reliable photosynthesis from LSST data. Okay, so we need new surveys, so we need to start thinking about which spectrographs. So there's no shortage of spectrographs coming online. But it didn't seem to me, at least, that there was a consensus about which spectrographs would be best, or what combination of spectrographs on offer will be best to get this kind of calibration sample. Okay, so we need to organize ourselves and try and work out where we're going to get this data from, who's going to organize the data collection, etc., etc. So I think the people who are involved in these spectrographs essentially need to talk to each other on a short time scale and perhaps try and organize the aim should be to get spectral information for every interesting LSST transit. So the kinds of things we could use are, foremost was discussed, probably more than some of the other instruments because it was discussed specifically in the talks. So for example, foremost has allocated 250,000 fiber hours to follow up LSST. So this is before community time, right? So you can apply for time over and above this allocation. And community time is of the order of 20%. Is that right? 20%. Okay, so foremost is attractive for spectroscopic follow-up. DESI will have secondary targets, right? So you're looking at an order of a few percent. You can allocate fibers to follow-up LSST. And then we discussed the sun effect shooter instrument. This kind of instrument will be good for single object follow-up. But this is a 4-meter telescope, so you're not going to go, you're going to struggle to get something at pi 5 or even close to that beyond the direction, let's say half. So there is a gap there that we need to work out how to fill. Anyway, so again, just like photometric redshifts, the calibration samples, we need to work out how we're going to effectively do spectroscopic follow-up of transients when LSST comes on. So again, it wasn't clear to me that we have a strategy, but it was clear to me that we need one. And so people who are, again, involved in these instruments need to talk to both each other and talk to the LSST people to come up with this kind of strategy. And it probably has to be done over a time scale of several months to 1 or 2 years. Alright, so the last thing I wanted to mention was imaging and low surface brightness science. So low surface brightness science has been discussed a fair bit in this conference. It's nice to see that people are excited about low surface brightness science. And we should be, because low surface brightness science is a brand new area, right? And this is going to be opened up by LSST. But at the moment, we don't really have tools to exploit or to do low surface brightness science. That's not really, that's not surprising because data hasn't been, there's no data really available that you can do this kind of science with there. But this is something we need to plan for. So I think the consensus, so there was some consensus that it's very hard to pick out things like tidal features in an automated fashion. Okay? So it's very hard to build that into your pipeline because you're going to run into all sorts of difficulties. So for example, if your sky subtraction is too aggressive, you might take out the tidal feature, etc. So the question is, what do we do? I think this is something we need to think about. So people who want to do low surface brightness science have to talk to people like Robert, who's going to be designing the pipeline. So I think those conversations need to start now, and hopefully they will start now. So one thing we discussed was crowdsourcing. Okay, so Bob mentioned crowdsourcing in his talk, and crowdsourcing has been surprisingly useful in both doing science with these kinds of data sets and also for checking things that come out of the pipeline. Okay, so for example, if your pipeline spits out the shape of the galaxy, you can crowdsource images and get people to tell you whether the stuff that's coming out of the pipeline is reliable or not, or at least pick out things which are clear. So the UK, for example, has experience with crowdsourcing. So Galaxy Zoo is an obvious tool that we can use. So I think we should start thinking about using crowdsourcing, especially in the context of those types of stuff. So the kind of thing we could do is we could take the images that, say, Robert is producing from screen cam data, and then develop tools which will allow users to essentially look at the image and just trace out the type of feature. And once you know where the type of feature is, you can then do photometry on the type of feature and then compare your photometry to models and to work out the properties of the stellar population in your type of feature. So I think crowdsourcing, in my opinion, is going to be important. It might even be essential to do this kind of low surface brightness. And we should actually think about crowdsourcing in the context of LSST. Okay, so I think that's all we had. We'll be happy to take comments missed out some points, so please fill in the gaps.
Comments, questions?
There's another follow-up instrument, which is the Gen 4 Hash 3, which is going to Gemini South. It's probably going to look, there are various proposals, it looks a bit like SOX probably. We don't know yet. There are, I think, 4 instruments that still be designed to follow up. And of course, the UK left Gemini as well.
We might join again, you never know.
That's true,
Yeah, no, wait a minute, because there is the
You
problem
don't know what the
with
hell
ISO.
we're doing.
Now there is the problem with ISO as well, I guess.
Yeah.
Am I right?
No, you, as long as we keep paying our
I
subscription.
remember this problem was already on the table when there was the possible separation of Scotland.
But that's
because-
different. That's different. It's totally different. The UK is a member of the EU. It's a Scotland problem. If Scotland is not a member of the UK,
Yeah, but now that you are no more,
These are fascinating topics, but they are beyond our. So these leaders, our fearless leaders of these workshops, did a lot of work to get to this point. So let's thank them all. They were great help to the song. So Darko would like to say a few words about statistics of the meeting and tell you happy journey and so on. So he will go now and we'll conclude with Katie Lyson after that.
Okay, folks, I do hope you enjoyed the meeting, and if you had a little bit of time to have to see some nightlife in this city, because it is pretty much vibrant, and I hear some outsides. Participants were here from 18 countries. And if we were talking yesterday about this, it would be the most participants, of course, from Serbia. There were about 26, 27 people. Then there were 14 people with affiliation from US. And yesterday I would say 41 people from EU. Today I have to say 31. Just the kind of. But we did have, we had 36 talks, we had 4 workshops for 3 talks here, and had 2 tutorials, and we hope that you got something from those tutorials, because people from the LSST were hard for that. And all in all, I again hope you got quite a bit about what LSST is going to be doing, what you are going to be doing with LSST, and what is probably the best thing that we had quite a few students who are the ones who are going to do the work. For me, even Mario, we are going to be close to the retirement when the things finishing with some other people. So it is good, great thing that we see that we had a younger population. We had 13 posters from people, and I hope that they also gave us a flavor what is going to happen, what is going to be size in the future. I mean, in the future. As I said, I do hope that you enjoy meeting, and see you at some of these meetings probably here in Belgrade again. Hopefully.
Thank you.
Cheers.
Again, this meeting was Darko's brainchild, so it wouldn't have happened without that. Thank you.
Yes, thank you, Doc.
And now the presentation by the best dancer at the meeting. As you learned last night at 2 a.m.
I don't know about the best, maybe the most vibrant, but I don't know. Anyway, I had a ball here. This was a fantastic meeting. I want to reiterate summary recaps this morning. I think that the balance between the science talks and the workshops was perfect. I think that's really the way of the future. When I was a young student, like many of you in the audience here, we sat through talk after talk after talk, and the interaction is what makes the communication really work, and that's why we have these meetings, that's why people get together. And I thought that the science organizing committee did an excellent job. So thank you to you and your team for that. I want to also reiterate the attendance by a lot of students, because it's always good to see young people coming up and getting involved. That's what makes things happen. They fill the pipeline. They become the people that will be retiring, as already mentioned, by the end of this project, and some of us well before that. And I want to then reiterate also the accolades that were put on the local organizing committee from DARPA last night. All the folks, including Dardana right there walking around, and all of her team, it was just fantastic. The events that you organized were fun. I think everybody had a great time, a lot of good food, a lot of good drink, good conversation. I met many, many people here, and for the corporation, that's really essential to meet the people. I can send emails all day, but to meet someone and sit down and have a real conversation really is what happens and makes things work. So it was a lot of fun. We had a lot of fun last night. So a recap. And then I want to thank Nigel. Stand up.
No way.
You wore a tie every day. I want everybody to notice that. The federal agencies have done their part in paying for the construction of the telescope. It's a big, big commitment from the U.S. Near 700. Well, it's about $650 million for construction. By the time it's done, that sounds like a lot of money, doesn't it? By the time it's done, it'll be $1 billion, which is a lot to build this thing, and it's going to be a true discovery machine. It's really, really exciting for everyone. So thank you for that. I will, on the part of the corporation, say that this was productive because, like I said, I met some folks. We've actually got a couple new MOAs while I've been here, and we have work in progress to get several more. Our goal is to meet the $100 million for the 10-year survey for the operations. We still have quite a shortfall and a way to go for that. And the other goal for the corporation is to raise $100 million that we can spend on you and the science community at large to provide schools and workshops and money to just do your science, okay? And these kinds of meetings are great. So that's our goal, and I'm very positive and optimistic. Robert, I'm very optimistic that we will meet that. And now I want to also just kind of close it with the announcement of the next LSST at Europe 3 meeting, which will be hosted by the French IN2P3 folks, Dominique and Pierre. They sent me a note and said we'd like to do it in 2018, and it'll probably be the same time frame, June, July of 2018. So I'm sure you'll hear more about that, and that's great. I think it's exciting that people are so excited. And I want to just say that if you are here and your institution is not a member of LSST, go back and talk to your directors and have them talk to your funding agencies, because it's important. The work is starting now, the preparation is starting now. You've heard all about that, and it's really important for all of you young people especially to get on board. It's going to be just a big data, big science, knowledge-based project. So thank you so much. I had a wonderful time, and I thank all of you for making it happen.